All right, let's check our answers for the dihybrid genetic problems practice for foil. Number 1, big A, big B, big A, little b, little a, big B, little a, little b. Number 2, big A, big B, big A, little b, big A, big B, big A, little b. Number 3, all of them are big A, big B. Number 4, all of them are big A, little b. Number 5, little a, big B, little a, little b, little a, big B, little a, little b. All right, for your answers for 6 through 9, number 6, little a, big B, little a, big B, little a, big B, little a, big B. Number 7, big A, big B, big A, big B, little a, big B, little a, big B. Number 8, big A, little b, big A, little b, little a, little b, little a, little b. And number 9 is all little a, little b. Yes, I see there is a typo on number 8. Should be big A, little b, big A, little b. So that right there should be big A, little b. All right, for the next section, suppose brown hair is dominant to blonde and tallness is dominant to short. So you should be using B's and T's. You're supposed to write the genotypes for the following parents. So for number 10, heterozygous brown, homozygous tall would be big B, little b, big T, big T. 11, heterozygous brown, heterozygous tall, big B, little b, big T, little t. Number 12, heterozygous brown, short, is big B, little b, little t, little t. 13, homozygous brown, homozygous tall is big B, big B, big T, big T. 14, homozygous brown and heterozygous tall is big B, big B, big T, little t. 15, homozygous brown and short is big B, little t, little t. 16, blonde hair and homozygous tall is little b, big T, big T. 17, blonde hair and heterozygous tall, little b, big T, little t. And 18, blonde and short is little b, little t, little t. All right, for the first dihybrid cross between these two organisms, they already set it all up for you. They already gave you the parents' genotypes. They already figured out the gametes and foiled them for you. And then they already figured out the F1 offspring. And then you were taking the F1 offspring and doing the cross to get the F2. And they gave you a whole key of what all the genotypes and phenotypes are. So all you had to do is finish the Punnett square. They gave you the first square and did it for you as big B, big L, and then you were supposed to finish in the rest of it. So going across, you should have got big B, big L, little l, big B, big L, big B, little b, big L, little l. Second row, big B, big L, little l, big B, little l, little l, big B, big L, little l, big B, little L, little l. Third row, big B, big L, big B, big L, little l, little b, big L, little b, big L, little l. Last row, big B, big L, little l, big B, little L, little l, little b, big L, little l, little b, little L, little l. And so at the bottom of your sheet, you're supposed to figure out just the phenotype ratios. How many out of 16 are black and short? So looking at your key, black is dominant, so that is represented by a capital B, and the organism has to be short as well. So those organisms have to have at least one big B and one big S to be black and short. Or not S, I mean L. So let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So your first number should be 9 at the bottom, black and short. Second one, black and long. To be black, it needs to have a big B, but long is recessive for hair, and so that should be 2 little L's. They have to have 2 little L's and at least one big B. So counting those up, you would have 1, 2, 3. So your next number at the bottom of your sheet should be 3. Next one is white and short. To be white, it's little b, and to be short, you need at least one capital L. So you have 1, 2, 3. And then lastly is white long, which are both recessive traits. And so that is little b, little l, and that is 1. So your number is 9 to 3 to 3 to 1, which equals 16. All right, for the next problem, they're telling you to cross a heterozygous black short-haired organism. So that's big B, big L, little l, and you're crossing that with a white short-haired, and so that is little b, big L, little l. So the first thing you need to do is get the gametes. So to get the gametes, you have to do FOIL. So for the first one, your F is going to be big B, big L. Your O is big B, little l. Your I is little b, big L, and your L is little b, little l. For your second parent, your F is little b, big L. Your outer is little b, little l. Your inner is little b, big L. Your last is little b, little l. These are the gametes, and those are what is going to go on the outside of your Punnett square. All right, so we're going to set up the Punnett square. And so I'm going to put at the top my first parent, which is big B, big L, big B, little l. Little b, big L, little b, little l. Little b, big L, little b, little l, little b, big L, little b, little l. And now you bring your letters together. So check your answers. Big B, little b, big L, big L. Big B, little b, big L, little l. Little b, big L, big L. Little b, big L, little l. Big B, little b, big L, little l. Big B, little l, little l. Little b, big L, little l. Little b, little l, little l. Big B, little b, big L, big L. Big B, little b, big L, little l. Little b, big L, big L. Little b, big L, little l. Big B, little b, big L, little l. Big B, little l, little l. Little b, big L, little l. Little b, little l, little l. So now they want you to do the phenotype numbers again. So how many are black and short would be how many have a big B and a big L. So you would count them up. 1, 2, 3, 4, 5, 6. So you should have a 6 over here. Next one is black and long. Black is dominant with a big B. Long is recessive with 2 little L's. And I see 2 of them. 1, 2. All right, white is little b, and short is dominant, so that would be 1 big L at least. So we got 1, 2, 3, 4, 5, 6. So your 6 should go there. And then white and long are the 2 lowercase letters for both traits, and that is 2. 6, 2, 6, 2 equals 16. All right, one more to go. All right, for our last problem with these organisms, we are crossing big B, little l, little l, with white short hair, which is little b, big L, big L. So the first thing you're going to do is get gametes. For the first one, your F is big B, little l. Your outer is big B, little l. Your inner is little b, little l. And your last is little b, little l. For your second parent, it's all the same. All of them are little b and big L. So those are the letters that you're going to put outside of your Punnett square. All right, so let me set this up. And now you're going to put your gametes for the first one up at the top. Big B, little l, big B, little l, little b, big L, little b, little l. I see pattern right away that we can skip this whole column is repeating. So I'm going to go ahead and put my arrows in because these are the same columns. You're just going to have to do 8 squares so far. All right, let's put in our other parents' gametes, little b, big L, for all the way down. So we have a repeat going down as well. So this box is going to repeat down and that box is going to repeat down. So really, if you figured it out, you only needed to do two boxes. So your first box is big B, big L, little l, and little b, big L, little l. So then when you answer the question, how many of the offspring are black and short? Black is dominant and short is dominant by big B and big L's. And so you would count them, and you would count all of those, which is 8. How many are black and long? Black would be a big B and long are 2 little L's, and there are 0 of those. White is dominant. White is recessive, 2 little B's, and short is dominant. That would be big L, and that's what we have. So we have 8 of those, and then we have none of the lowercase for both. So 8 to 0 to 8 to 0 for your offspring. All right, genetic problem number 9. A cross is made between 2 koala bears. Each koala bear is heterozygous for round eyes and fuzzy fur. Round is dominant over almond eyes, so you should be using R's. Fuzzy fur is dominant over rough fur, so you should be using F's. The genotypes of the parents, number 1, the parents are both heterozygous for both traits. So both parents are big R, big F, little f. Number 2, what are the allele combinations in the gametes? So then you would do FOIL. So the allele combinations are big R, big F, big R, little f, big F, and little r, little f. And so then you're going to set up your Punnett square. And you're going to put those gametes up at the top. And both parents are the same, so the same combinations of letters are going on the side as well. F's are difficult to make sure you distinguish between your capitals and your lower cases. All right, so then you bring your letters together. Big R, big F, big F. Big R, big F, little f. Big R, big F, big F. Big R, little L, big F, little f. Big R, big F, little f. Big R, little f, little f. Big R, big F, little f. Big R, little f, little f. Big R, big F, big F. Big R, big F, little f. Little r, big F, big F. Little r, big F, little f. Big R, big F, little f. Big R, little f, little f. Little r, big F, little f. And then little r, little f, little f. So then what you need to do is to do the expected phenotype ratio of the offspring. And so you have 4 combinations. And so then you would have round and fuzzy. So for round and fuzzy, I'll try and squeeze this on here. You need at least 1 big R and at least 1 big F. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to have a 9. All right, and then you're going to have round and rough. Rough is recessive, and so you need 2 little f's for that. And round is dominant with a big R. So that is right here. 1, 2, 3. Next one is almond and fuzzy, which is big F's. At least 1 big F, but you need 2 little R's for almond. 2 little R's for almond and a big F is right here. 1, 2, 3. And then you're going to have one of the lowercase ones, which is almond, and I can't fit this in here, and rough. So one pattern that you should notice is that when the parents are both heterozygous, remember our parents were heterozygous, if both of them are heterozygous for both traits, you will always get a 9 to 3 to 3 to 1 ratio. So it's kind of a checkpoint for you. For the genotype ratio, what you would be doing is counting up all of these genotypes and writing in the number out of 16. All right, so if you counted all of your genotypes up by going through the Punnett square and I'm just counting them, you would have got 1 big R, big F, big F. 1 big R, big F, little f. I'm sorry, 2 of those. 2 big R, big F, big F. 4 in a diagonal of big R, big F, little f. 1, big R, big, change it to a little f. 2, big R, little f, little f's. 1, little r, big F. 2, little r, big F, little f's. And 1, little r, little f. And if you add all that up, you get 16. This is the worst problem you will ever have. When both parents are heterozygous for both traits, this is what you end up getting. Otherwise, you should end up getting repeats and arrows on your Punnett square and not so much complication. All right, so genetic problem number 10, predict the results of a cross between a heterozygous round and homozygous tall crossed with a homozygous round short plant. So those are your genotypes of your parents. We're going to do the FOIL to get the combinations that will go on our Punnett square. All right, so our first parent I'm going to place up at the top. My F is big R, big T. My outer is big R, big T. My inner is little r, big T. My last is little r, big T. So we're going to have repeats, going across like that. All right, second parent is big R, little t, all the way down. So this is nice because we only need to do 2 squares if you figured that out. First square is big R, big T, little t. Second square is big R, big T, little t. All right, for the question it says, what are the gamete genotypes produced by the parent? Those are your answers to FOIL. So the first question are all of this. You should be listing those. So you should have 8 answers for that first question. What is the genotype ratio for the offspring? The offspring are inside your boxes. So you write down your genotype and count them. You should have got 50% big R, big T, little t, and 50% big R, big T, little t. All right, and then for the phenotype ratio, all of them have a capital R and all of them have a capital T. So it is 100%, and you go back up to the problem, round, tall plants. And that finishes up genetic problem number 10. All right, in mice, the ability to run normal is a dominant trait. Mice with this trait are called running mice with a capital R. The recessive trait causes mice to run in circles only. Mice with this trait are called waltzing, little r's. Hair color is also inherited. Black is dominant over brown. So we're going to cross a heterozygous running, heterozygous black mouse with a homozygous running, homozygous black mouse. So that's what your genotype should have been for your parents. Okay, we're going to do FOIL and set this up. FOIL for the first parent is big R, big B, little b, little r, big B, little r, little b. Second parent is big R, big B, all the way down. So there is your repeat pattern going all the way down. So you only need to do 4 boxes. Big R, big B, big B. Big R, big B, little b. Big R, big B, big B. Big R, big B, little b. All right, all of them have a capital R and a capital B. That's what I noticed right away. So that makes it easy. Genotype percent, however, all of these are different. So it's going to be 25% of each. On a test, make sure you write that out. Phenotype percent, they are all 100%. What did the R represent? Running. And the B, big B, represents black hair. And that finishes up genetic problem number 11. All right, same type of problem. Cross a waltzing brown mouse, little b, with a waltzing, forgot my little r. Brown is recessive, that's little b. Cross that with a heterozygous black waltzing mouse. My R's are first, so my waltzing needs to go first. So little r, big B, little b. Okay, so I'm going to set up my cross. I have to do FOIL. First parent FOIL combinations are all the same. That gives us repeats going across. Second parents are little r, big B, little r, little b, little r, big B, little r, little b. So you do your Punnett square, you only need to do 4 boxes. Really you only need to do 2, but we'll do all 4 because there is a repeat there. All of them are going to have those 2 little r's, which means all of them are waltzing. But we do it as a dihybrid. So, first question was genotype. There are 2 genotypes. 50%, little r, big B, little b, because that is all of these. That one. And then 50%, little r, little b, and that's those. Phenotype percent, or phenotype is, all of them are waltzing, and half of them are black and half of them are brown. So we're going to have 50% waltzing black and 50% waltzing brown hair. And that finishes up the second part for problem number 11. All right, genetic problem number 12. This is the last one, the last set. Reindeers are dominant for possessing a black nose and recessive for having the red nose. They are also dominant for having webbed hooves, otherwise they have split hooves. Cross a reindeer with homozygous webbed hooves, so that is big H, and heterozygous black, which is big B, little b. Cross it with a red nose, so that is little b. Make sure you keep your H's first though. Split hooves, which is recessive, little h. Okay, let's try that. Foil for the first guy is right there. Your second one are all h, little b's, all the way down, so we have a repeat going down, which is always nice. All right, so first one is big H, big B, little b. Big H, little b, little b. Big H, big B, little b. Big H, little b, little b. Genotype percent. Well, what do we have? We have 2 different ones, right? So it's going to be 50% of big H, big B, little b, and 50%, because that counts all of these, and then we got to count those, 50% big H, little b, and that counts the rest of them. And then for phenotype, it's 50% and 50%, so it's 50%. What does the big H represent? Big H represent webbed, and the big B represents black nose, and then my other reindeers are 50% webbed, but they have a red nose. Now there's an extra question. Also answer what the probability is of having a reindeer like Rudolph. Rudolph is famous for his red nose, so your answer should have been 50% for Rudolph, because there's 50% for red. All right, one more problem. Cross a heterozygous black-nosed, split hooves reindeer, so that's little h, with a heterozygous black nose again, homozygous webbed hoof, big H. So this time my B's are going first, but it doesn't really matter as long as you're consistent. I just do it in the order of the problem. So foil, big B, little h, little h, big B, little h, little b, little h, little b, little h. So I have a repeat going in one square. Second parent, big B, big H, big B, big H, little b, big H, little b, big H. So I have a repeat of one square as well. All right, so you fill in your Punnett square. Big B, little b, big H, little h, big B, big H, little h, and little b, big H, little h. So it's a little different here. All those genotypes are different. No, they're not. these are the same. So you're going to have, what do we got to do first? Genotype. Genotype is going to be 50% big B, big H, little h. 25% big B, big H, little h. And 25% little b, big H, little h. And then for phenotype, 3 of them, all of this, 3/4, 75%, have the big B and the big H. So 75% are black-nosed and webbed feet. 25% are little b, which is red-nosed, and they still have webbed feet though, webbed. And then that one extra question, what's the probability of having a reindeer like Rudolph? You're looking for the red, 25%. And that finishes up our dihybrid. Please hold on to these to prepare yourself for our upcoming test.